Welcome! We calculated weight of evidence and information value for the grade variable, but we have to make the same calculations for at least 5 more categorical variables. To achieve that, we can use the same code many times, sure, but wouldn't it be easier if we could somehow automate these calculations and run them all at once for any variable of our choice? Well, we can achieve this by writing a function that performs these calculations for any given pair of categorical variable and dependent variable. Let's define our function with the def statement. We'll name it whoa discrete. We mentioned the function should perform the calculations for any pair of categorical variable and outcome variable, so we must specify these two as parameters of the function. In pandas, the variables come from data frames. Remember that our independent variables are in one data frame, the inputs data frame, and our dependent variable is in the targets data frame. So, it is good to specify the independent variable's data frame as a parameter of the function first. Next, in round brackets, we itemize the parameters. Let's name the independent variable's data frame df. Then let's name the discrete local dependent variable discrete variable ning. Finally, let's define the local outcome variable data frame as good-bad variable df. Note that these are local variables. They will be used only by this function. Later, when we apply the function, we are going to execute it with the variable names from our data. So, we already wrote some code for the grade variable calculations we can use. The first thing we did is to merge or concatenate the independent variable and the dependent variable in one working data frame. Let's copy this expression. Let df be equal pd concat. And here we need to make the expression in the round brackets work for any variables by typing the function parameters instead of the specific references to our data. So we take the df variable, which, before the execution of this line, is still the source data frame we pass to the function. From the source independent variable's data frame, we first take the independent variable. Its column name is a string stored in the discrete variable name parameter, and we concatenate it with the dependent variable data frame, effectively concatenating it with the dependent variable only. Great! This statement will overwrite the original df variable with a 2-column data frame, the independent variable and the dependent variable. What we did next was to calculate the number of observations and the proportion of good borrowers for each grade. Remember that the number of observations was the count of the rows and the proportion of good borrowers was the mean of the values of the second column of the working data frame we had. Note that in the expressions we wrote, we didn't refer to the columns by their names, but by their indexes. Thus, no matter what the independent and the dependent variable were, the expression would have performed the same calculation. This is the exact expression we need in our function. Hence, we can just copy it into our function and change the name of the working data frame from df1 to df. The same goes for all subsequent expressions. They are all parameterized, so we can just copy them into our function, provided that we change the name of the working data frame from df1 to df. Let's go through it quickly. We keep only the first, second, and fourth columns. Then we assign specific column names. We calculate the proportion of observations from the total number of observations. Then we calculate the number of good borrowers and the number of bad borrowers. And then the proportions of good borrowers from the total number of borrowers and of bad borrowers from the total number of borrowers. Here we calculate weight of evidence. And here we sort by weight of evidence and reset the index. With these two expressions, we calculate the differences in proportion of good loans and weight of evidence. And finally, with the last two expressions, we find the information value. As with the calculations for the grade variable, we've overwritten the working data frame multiple times and added columns to it to store our results. In order to see our results from the execution of our function, let's instruct it to return the working data frame. Great! Once we run this code, we will have defined the function discrete. That means we can apply it to other discrete independent variables from our data. Let's check if it's working properly. We apply it to the grade variable and then assign the result to another working data frame called dftemp. dftemp is equal to our function discrete. Its first argument is the data frame where our data is contained. The second and third arguments will be the independent and dependent variables we are interested in. These are grade and good/bad. We enclose grade in quotation marks as our function only takes the name of the variable. Now let's display the data frame dftemp to see the result. Awesome! It's identical to the result from the calculations we performed for the grade variable. We are all set to apply the function to other discrete variables.